Let's move on to the next question, guys. This is a question, not exactly based upon the semiconductors, but on the concept of semiconductor diodes. Okay, so the forward and reverse bias concept. It's based upon what, guys? Forward and reverse bias concept. Okay, look at this question, guys. Look at this question. A 2-volt battery is connected across AB. Means, A is 1 point, B is 1 point. Across the AB, we are connecting what? A 2-volt battery. The value of current supplied by the battery when in first case the battery's positive terminal is connected to A, and the second case positive terminal is connected to B. First case, what you are doing, you are I'll just draw the diagrams here, guys. First case, what you are doing, you are connecting positive terminal to A, which means what? The negative terminal will be what, guys? B. So if you see, this is the circuit, right? Diode 2, 10 ohms and 5 ohms. In this arrangement, right, guys, the first case, what we have, so we see that the diode 2 is what? Reverse biased. Correct or not? The diode 2 is what, guys? It is a reverse biased diode, which means what? The current that it will allow will be what? Very, very less. Means for the sake of practical calculations, right, we can almost neglect the branch, because that branch is having a reverse biased diode whose resistance value is going to be very high. So if you neglect it, right, then what we have, there is just a 5 ohm resistance. There is just a 5 ohms resistance. Means what will be the current? The battery voltage is 2 volt. So current is equal to what, guys? 2 by 5, which will be equal to what? 0.4 amperes. So first case, by that still we can conclude the answer, guys. The first case, right, where we keep the positive terminal to A and negative side to the B, right, the current will be equal to what? 0.4 amperes. By using that itself we can conclude the answer. What is the answer? Option B will be the answer. But in any case, we can look at the other one also. What is the second situation? We connect the positive side to B and the negative side to A. Okay, so as a result of it, what we see is now the situation will be different. What do we see? It is like the D1 diode 1, right, is now reverse biased. We can see B is positive, right, the positive is connected to negative. Diode 1 is what? Reverse biased. So we can neglect that branch, because that branch is going to be having very high resistance. So now this is what we are left with. The branch where we have the diode 2, that is the leftover. So the voltage is 2 volt. So current in this case will be equal to what? 2 volt by 10 ohms, which is equal to what? Nearly 0.2 amperes. Check this one, guys. Most of us are able to get the answer. What is it? 3 will be what? D. So this is about what? How we are arranging the diodes, whether the diode is forward biased or reverse biased. Okay.